We'd like to begin with our next, welcome back. We'd like to begin with our next presentation. I'd like to welcome Mr. Mudit Mittal, Technical Director, and Ms. Stuti Gupta, Co-founder and Director of BlueKei Solutions. Together, they will co-present Systems of Systems Modeling to empower decision makers in drone-based services and an application in agriculture. So please welcome.
Thank you very much. Shall we get started?
All right, I guess we can get started. Greetings, everyone. Excited to be here. And today, like John mentioned, we are going to present to you our work on modeling for mission engineering, the drone, application of drone-based services in agriculture, and how we are using the modeling and simulation in AnyLogic to empower decision makers in that space. I don't see the presentation. However, yeah. Okay, great. Next slide, please. We're going to talk through some of the potential and challenges, how we have used a systems engineering approach for drones in agriculture, which actually informed very logically how we set up the model, which Mudit will be talking through, and some of the questions that the decision makers ask and often rely on thumb rule, whereas the model can, give them something closer to the insights they might be looking at. And then how it all ties to mission engineering, whereas our application is more in the agriculture space. Next slide, please. I want to set the context before Mudit gets into the, how we set up the model and how we are leveraging it. Setting the context for the drones industries and the opportunities. Mudit, next slide. Very recently, 2-3 months back, a lot of rules were modified. Earlier they were very stringent. Now drones have been in India for last 10 years. However, the approvals, a lot of update was made very recently, 2-3 months back, boosting the more applications in this space and making India the drone hub for the world. At this moment, India is one of the largest importers, whereas the vision and the mission is to be self-reliant India, that you see as Atmanirbhar Bharat. The rules, some of the examples of the rules I'll say, and many of these are very useful as we do they form as our inputs, constraints, requirements in the modeling itself. It's allowing more proliferation, obviously in the defense as well as in commercial applications. As simple as the number of forms a drone company has to fill has been reduced from 25 to 5, 300 to 5. The range of the drone has increased from 300 to 500 kgs. The restricted areas in which the drones can fly, in the restricted areas, the perimeter has reduced from 45 to 12 kilometers. So it is giving a big boost to the surveillance and mapping and monitoring that the government as well as the private need to use the drones for. So the guidelines are progressive and they are path breaking. And obviously they support boost the geospatial industry, which in turn boosts the economies and the startup ecosystem in the country. Like I mentioned, government is the largest consumer of these technology. However, there is a lot of privatization that is coming in for security and quality standards. So this slide, it shows a picture of the potential of drone market in India. As you can see, the largest is the defense application. However, there is also commercial and counter UAS and other applications that are being considered. And, a US dollar 40 billion market is what what is being predicted as the potential of this market in India. If we move to the next slide. We did, as we are working with many of the players in this space, this is not a exhaustive stakeholder analysis. However, we are categorizing the key players in three categories. One is the drone manufacturers, the technology integrators, and the drone-based service providers. So now each of them have different maturity levels in terms of adopting the technology and the preparedness. They come with their own opportunities and potential and challenges. So for instance, for drone manufacturers, building resilient products with fail-safe provisions and features and optimal functionalities is a key focus. For technology integrators, managing variants, product technology roadmap, because many of these will be leveraging technologies to whether the application is for surveillance or for delivery of product or things like that. When it comes to drone-based services, which is largely the category that we are being closely working with, for them, design for how the system itself is designed for service providers, as well as validating for the mission scenarios. So I'm a service provider. How do I know whether the number of systems I have cater to the actual ask that the end user has? So that led to this whole exercise with a customer on establishing mission scenarios. So if we go to the next slide, where I talk about, so when we say mission systems engineering, of course, it comes from defense, but we are using analogously for other applications as well. And so terrain mapping or rescue missions, and all of these, for one, you'll not be using an individual system. Even if it is multiple drone system, you will still be interacting with several other entities in the ecosystem. So it becomes important that while I may have more control over the behavior of the system that I own, but I necessarily don't have control over the behavior of other systems. So how do I establish some of these understanding of the system behavior right up front as I'm designing my system? And there are several applications. Actually, some are already in use, like Coal India is using drones to monitor illegal mining and pilferage. Now, these are individual systems which are probably giving some live feed or some sort of movement and tracking activity. The government wants to use for management and digital mapping of national highways and broadening of roads. So they're sort of more for strategic use that, okay, next 10 years, which ones will be targeted for broadening, are the current ones sufficient, and things like that. So it is meeting even strategic objectives. And so several different applications, not just for defense, but several other industry verticals. And the one that we are addressing in our presentation today is specifically for agriculture. Now, that led to why mission scenario planning could be complex, right? So because as you see, there are several decisions that in the mission that the stakeholders need to create. So one, what kind of system will suffice? How many systems, how many drones would I require? Which other ground units it should be interacting with? What's the environment, and does it impact the performance of my system? Spatial, temporal, these are environmental factors or what exists in the mission scenario. And the questions that are being answered is, what is the total cost of my operation? Or what is the probability of success that I'm going to achieve the objectives of this mission, given the combination of systems that I have utilized? Or what are some possible risks that can come because I'm interfacing with other systems in my operational context, for which I have some idea of their behavior, but not when all those systems start interacting with each other. So, and there are several other questions, so I'll just leave it at there and hand it over to Mudit, who will talk through the application in agriculture and the modeling part. Over to you, Mudit. Thank you.
Yeah, thank you, Sudhi. Thank you for setting the context. So what we are going to look at is how drones application can be utilized within the X scenario, trying to understand the overall picture and take out one of those applications as our modeling scenario. So on the left that we have is a very like a life cycle of how you go about right from preparing of the soil to sowing of the seed, adding fertilizers, irrigation, weed protection, harvesting and storage. So that becomes a life cycle of the crop. And among the life cycle of the crop, there could be several applications for drones. So for example, GIS mapping, weed detection, spraying pesticides, etc., etc. Another news was that probably they're going to mandate use of drones for insurance of crops. So how can we look at these various applications and come up with the best possible solution, which is optimized both on the perspective of the performance in the time as well as lowest cost possible. So the example that we're taking today is the spraying pesticides and fertilizer example. And I'll be walking you through a scenario or a chat that I was having with one of my customers. So what he described was that it is going to be a multi-field operation. And what we have here is a SysML diagram to sort of easily describe what the architecture is. And then we'll go into the AnyLogic model to show a parallel to this current context. So what he described is that it's going to be a multi-field operation. They are going to be the contract or the drone provider or the service provider. And what they are not sure of is how many drones should they deploy. Now, one of the contexts within that is spraying a single field. And when you are spraying on a single field, you can have several pieces come together, like the drone itself, the crops, the field, the drone support system. So in the drone support system, you require a drone carrier that is going to carry the drone around from one field to the other field. There's going to be drone operator who's going to operate the drone. There could be technicians. Maybe if there's a breakdown or you need to change the battery. Then the drone charging infrastructure. And maybe a few more things could be there. So we can easily see that there are so many things in the mix. And now we can start to identify, okay, these all can become individual agents. And what we want to observe is how the overall behavior emerges out of it. So this is a real conversation sort of depicted in a SysML diagram, wherein the drone application contractor wanted a huge number of drones from the drone manufacturer. And however, the drone manufacturer also was sort of an internal stakeholder within the decision. And he said, no, I cannot supply you so many drones because they'll be sitting idle. What we want is a complete utilization of the drones. So how can you optimize that? So these are the kind of tussles that happen between stakeholders, and they could be more. And what we wanted to see is how can we help using AnyLogic or agent-based modeling to come up with a solution. There are some other decisions that need to be made. So for example, around the support system itself, what should be the count and the type of support system? How many backup batteries do I need? How many drone carriers do I need, right? Do I need a drone operator or a technician always on the ground? Or can that technician be moving around as required, right? And now all of these things will depend upon several factors. So, for example, the field size, what is the type of application that you having, how far the field is from your base location, and then that also needs to tell you how many base locations do you need, right? So several things are there, and then you can also decide upon, okay, maybe I'll have these many number of drones, or the type of drones that I need, right? So there could be several type of drones that have different performance characteristics and how much load carrying capacity they have. So all these variables come into the equation now. So the approach that we took was we started identifying the key architectural decisions at system of system level, which were sort of the things that I explained before. Then try to build the dependency between these stakeholder decisions, model the behavior of individual systems, and try to understand the emergence. So that was the overall approach. And now I'll go a deeper dive into the actual model. So what I have here on the right is the SysML diagram that I explained. And on the left is actually a snapshot of the model in AnyLogic. And you can see there's a parallel between the agents or the classes that we have and the blocks or the classes we have in SysML. So for example, I've created here for a drone carrier. Drone control center is like a central controlling agency that sort of allocate drones to field and deploy them, controls the queue, and then of course field and the main agent. So I'll just quickly go about how we model the environment. This is a snapshot of an actual area in which there are about 17 fields that we have considered. And so over here we have the agents. And then what we are also modeling in here is shift. So few things that we have modeled in this is that uh, the drone operators will have their own shift. And maybe this application of Spring won't be happening during the night. So for example, the shift could last for 8 hours or 9 hours, might start early morning around 6 a.m. So that is over here, the graph depicts sort of the cycle of the day shift. In the night time, no one is working. What we are also modeling in this is how batteries are going to deplete, and you have to change them. So I'll show you that in the next slide. So this is the drone behavior. It's a very simple state machine diagram that we have built for this. However, we are tracking a lot of parameters and a lot of inputs. So for example, what is the charging rate for a drone? What is the discharge rate? What is the average flying speed? So right now we have considered a constant flying speed. However, this can also be dynamically modified. Then we have the land coverage per minute. This will depend upon the application and the type of drone. And then how long does a battery last? So instead of taking ampere hour, we have taken how much time does it last for that particular application to keep things simple. And then basically a drone waits till it receives an instruction to get deployed. It goes to the field through a carrier, and then drone field application. So that happens, and then there are two different states in which it could go. One is the shift is getting over, so it goes idle that time, or the battery is being swapped. We could also model third condition of a breakdown, or maybe a depletion of the spring content. So all those scenarios can be modeled using the states over here. Another one is modeling the field itself. Right now, what field agent is doing is just getting the drone job done and sort of tracking how much field area has been covered. And finally, the drone control center, that is the one that is sort of creating the decisions. And over here are the decision points. It also goes into a pause mode once there's a night shift, and then keeps on sending the drones as the queue gets clear. So with that setup in mind, I would like to show you a quick demo. In the demo, what we have, sorry, I'll just go back. So in the demo, what we have is right now we have configured three parameters, which is setting the number of drones, what is the battery capacity, so just to see how it would impact the overall duration, and what is the shift length. Now this might get varied based on the time of the year or what the contract that you have with the employees. So on an average, we have taken 8 hours per day. So right now, this simulation that is running with a single drone, and this will show you how much time it is taking in overall to complete the simulation. So the simulation time is running in minutes. However, on the right, we start getting a lot of debug messages about what's the current situation. So right now we can see that the application of the fertilizer was constant, and then it has gone into a shift over. So basically it's night time. And we are also tracking the shift over here. So we'll be able to see how many days it has passed. And we are also able to see on the right that how many times the battery has been discharged. So basically what we are assuming is there's a battery pack, and every time battery gets discharged, a new battery is swapped, and that takes about 10 minutes to change a battery. So we are tracking the number of times the battery has been changed and number of days that have passed here. Okay. So just to speed it up a little. Okay, now we are running on a higher speed, and we can see it takes about 41 days or 42 days to complete this. About 150 times the battery was replaced with a single drone application. And over here, we have changed this to, let's say, okay, maybe 9 hours and number of drones to 4. And then how much time would it take to really complete the overall operation? Now, what we have here is that the drones are being sent in a sequence to the number of fields, and that sequence has been pre-decided. What can also be done is that we could change that sequence dynamically based on the location and what is the most optimal path. Okay. So I'll maybe just quickly go ahead. Okay. So it takes about 10 days to complete this simulation. Okay. So here is a snapshot of the simulations that were run by changing the number of drones. So on the x-axis, I have is the number of drones, and the y-axis that you see in blue is total simulation time taken in days, whereas orange represents the number of times the batteries have been changed. So we can see that after a number of 4, it really doesn't matter how many drones you deploy. The number of times the batteries have been swapped is fairly constant. In fact, it doesn't really matter because the energy consumption would be similar. However, the time it takes is probably best around 3 if you look at the cost to number of days. Now, if it is really a very critical mission, you might go to 4. But then 3 is what seems to be a pretty good number over here. So now what I would like to share is some snapshots of individual simulations, which give you a little bit more insight of what we learned by running these simulations. Now, one thing that came out straightforward was that the number of days would vary depending upon the number of drones. However, one thing that can also be observed is that the number of times the battery is being swapped per drone also varies by where it is being applied. So let me quickly run it through. So when we are running 2 drones, one drone is working pretty hard and the other one is a little less. If we look at it further, the distribution is pretty different, you know. So 2 drones are working to their full potential maybe, and this one is not being utilized completely. It keeps on changing as we keep on increasing the number of drones. So what can be observed from this is that we need to optimize even not just maybe the number of drones. What we also need to optimize is the path that they follow. What we need to optimize is when and where should they be sent so that they are fully optimized. So those are few learnings. I'm just quickly checking the questions. So few learnings beyond the number of drones. Deploying more drones did not help, and that is actually a very good feedback because you could deploy a few more drones as backup plans, but then beyond that, you don't have to invest in that. So that gives you an idea about the costing of overall system that you want to deploy. The number of battery swaps was also fairly constant, irrespective of number of drones, which actually goes well with the physics. And then scheduling deploying of drones as per following factors is necessary to optimize results, which is the field location. So right now, the field locations were considered, but they were considered in a sequence. So I think the next step would be to optimize the path planning. And so whenever you are planning it for a specific scenario, for that, the path plan needs to be generated. The field size, yes. The drone capacity, which was fairly visible that by changing the drone capacity, you could obviously get it done in under less time. And then the working schedule of operators and battery capacity. So these were the factors that were directly impacting the overall performance of the mission. Now, a few challenges that we would like to share and our approach. So basically, if you see the battery life and the projection of battery swaps, that is a complex, high fidelity model in itself. Because what happens is with life, the hours that we work in are
I think there is a blip in Mudit's internet connection. So taking on from here, so here as you saw the context of the model, uh, the accuracy will increase when we have required detailed, the GIS survey of the space that we are evaluating the application for, how much, and especially intra-field if there is a requirement. And also there's a need to add fidelity related to the type of spraying required, because the payload essentially will impact the performance of the system itself. Another one that we had was the definite need for path planning as a pre-work, which is a big investment because that requires not only seeing on ground, and obviously you cannot model for each and every obstacles within the path planning, but you can have a ballpark. But if you need detailed path planning, then you need to actually map out where is the well, where are the trees, and within the field and things like that. And especially India, there is a smaller land holding size, so that causes more complexity. And then, of course, I guess everyone in the audience, especially the whole community of modeling and simulation, is how do you actually say that it's a good model and validate the theory that we have. All right, so actually Mudit was sharing the screen, so we lost the presentation itself. But just ending the presentation, we were almost at the last slide. The logical extension from here on that we're working with a few customers is to, add on a look at how they are taking in some of the technologies like weed identification or health monitoring of crops, and uh, uh, for some of those use cases, geofencing planning, so that the animals don't impact the agricultural crops. So some of these are use cases that are of interest, and if the drones can be utilized to map some of these, and obviously the increase the fidelity of the machine engineering modeling itself. All right. I'm just scanning for questions. Maybe we can take that. Last 2 minutes left. Do you think there's a question from the audience? Do you think should be possible to use drones for process mapping? Well, I'm not particularly sure if we can enter in the comment what process you're referring to. Can we get this model file for study purpose? Yeah, we can create a version of this file now. This one, obviously, a lot of it is for the customer application itself. So for customer application itself, so we'll modify one that we can, share for the purpose of the community as well. One last question was, are the drones for 8-hour shifts or 24-hour shifts? So it actually depends on the application. Some of the agriculture applications cannot run for 24-hour shifts because of the crop condition. But it's easy to build it in the model, whether it is 8-hour or 24-hour. All right.
Okay. Thank you, Studi, very much. Thank you, Mr. Mudit. It's a shame we lost his audio or his video, but that's okay. These things happen. You stepped in with grace. Thank you very much for that.
Thank
If anybody has further questions for our presenters, please feel free to reach out to them through the platform. You can find them on walkthrough, and you can see the speakers' bios and ask them questions directly. Now I'd like to bring up our